The next speaker who is coming up on stage here, he definitely has the insights in his business. 25 years plus experience in robotics and automation are on his list, with a strong emphasis on emerging technologies, new application areas, and strategic marketing development. So that's a lot of ticks on the list. Throughout his career, he has held senior roles, plenty of them, in global industrial strategy, business development, and the regional expansion. And that's now one thing. We're not just focusing on one market, we're talking about regions of advanced robotic solutions. Currently, he is responsible for driving commercial growth and shaping the strategic direction of industrial robotics across European and MENA, Middle East, North African markets. Please welcome the head of sales of Denso Europe, Carsten Busch.
Very much. I'm afraid I'm not able to continue in the same way as you did. Otherwise, probably the hall here would be empty in about less than 2 minutes. So I'll skip this. Okay, yeah. Thank you for being here. I know it's late afternoon, second day, so I hope not that you fall into sleep now. But nevertheless, I will try to bring a little bit one topic that has been already on stage yesterday and today, and I will talk about standardized communication for robotics in a little bit parallel, but not exactly in the same way as the SRCA. But I thought it might fit together. I called it Open Controller Interface Architecture, enabling flexible and versatile robot application development. Quite long, and I hope I bring this a little bit closer. So, yeah, first of all, just very quickly, Denso. Who is Denso? So, we are, some of you might know, we are the second biggest automotive tier one automotive supplier in the world. We are entitled from Toyota in 1949, independent, and so mainly it is an automotive tier one supplier, but since more than 50 years, Denso also has own robots. We develop, we manufacture own robots. Why? Because 50 years ago, the first robots came on the market, but mainly for spot welding or arc welding, so bigger robots. But if you're in this area of small and precise and fast and accurate robotic applications, honestly, they were not really the right robots in the market. So about today, roughly about 150 robots installed worldwide, about more than 20,000 robots installed in own Denso automotive factories all over the world, about 160 factories all over the world, which is quite unique. So we have a very difficult insight internal customer who is pushing us continuously on one hand innovation, on the other hand on quality and everything that is related to this. There's one thing that maybe also to make a little bit more advertising, you know, probably this year, this is called a QR code. It has been developed in the beginning of the 19th from Denso for Toyota, the warehouse. So unfortunately, it is a QR code and a Denso code, otherwise we would be probably better known in the market. So these are just some numbers, so quite large company. Unfortunately, this 9% of the invented into R&D of the $50 billion is not in robotics. Otherwise, would be probably a little bit more about robotics that I could talk about. Just to see, so these are our portfolio on articulated 6-axis, small and mid-size, in different range, different payloads, different reaches. Also the SCARA robots, quite large range of SCARA robots, different payloads and reaches, different protection classes in different industries. And also since 2018, the collaborative robotics, both on portable, table-based, as well as larger ones, in order to have a complete portfolio. Maybe just to mention, interesting that we in Europe don't make the big biggest business in the automotive Tier 1 industry. We have them, of course, as well, but much bigger in other industries outside, which is not too bad, especially at the moment. Now talking a little bit about what is the topic for today. So, listening to customers, what are the requirements for a simplified robot integration? So when we listen to them, we say, okay, they talk about easy, seamless integration of factory devices, say uniform protocols in order, programming languages that is in different partial devices more uniform, simplify and standardization in the communication, and on the one hand on the devices and on the other hand on the software applications. So finally to have a greater flexibility and also to the change in production and product specifications. I will get back to this also with some examples later on. So these are typical examples and how to implement this. And I will give you an example what are the typical state of today. It's going to change. We have heard yesterday and today about what's going. So we have on the one hand the application, the different software tools on monitoring, on controlling in such a machine or in a factory line. And on the other hand, you have the various devices, not only the robot, but you have motors, you have PLCs from Siemens and Rockwell and so on. You have motors, you have linear tracks, you have vision, cameras, you have scanners, and how to connect them. Well, you have proprietary interfaces, you have own protocols, you have specific languages. So it is complicated, long development time, it is high cost on development, is complex, and also the maintenance. So wouldn't it be much easier if you could actually just connect them to some kind of engine in the middle, some kind of middleware, that you on the one hand have your application, different applications in one structure, and then you just simply connect the different devices together. So, in order to exactly shorten the delivery time, to lower development costs, to simplify use and maintenance. And actually, this is a consortium called Orion. It's established in Japan. And it shows, on the one hand, you have the application layer, where you actually then program for a complete machine, including different devices, in one language. For example, in high-level languages like Python, C++, C#, Java, in ROS-based or whatever. And on the other hand, you have the devices. You have this layer of provider layer with the robot, with the linear tracks, PLC, and so on. And in the middle, you have the middleware. And this middleware is actually handles the communication between the software and the devices. And as you can imagine, this makes it much easier. And so that means doesn't matter if you have vision, or can be Cognex, Bart, or whatever, if it's PLCs from Siemens or whatever, you can simply connect this. You have up to 200 providers already established. That means there's nothing that needs to be developed. And on the other hand, you even can create your own providers into this. And interesting, it's already established since more than 20 years, so it's even established in an ISO norm. So it is not so well known here in Europe. Those machine builders who really are in a very close relationship with us and they're using this, they're a big fan, they don't want to do anything else. What I want to say is it's very similar to SRCI. Standardized communication makes life easier. I give you here one example. This shows two robots with a feeder system, with a vision, and this is all connected to one controller programmed in one language, and even in this way, but without a PLC. So you run this all on the controller, and it's a very simple structure. You see, this is for the fashion industry, yeah? So pretty cool application. and it shows how to handle also this quite complicated task in a very simple way. The next one is something that I want to give you a little bit a view of what I call the next generation of a production line, to be more flexible. This shows an example of a Denso factory in Japan, showing the assembly line for EV parts. And the problem is that you have here more variants, more variants in products, more variants when you need to switch. You need to have a new way of flexibility. And instead of having a fixed line with one conveyor and the fixed station where the robots are fixed on the ground, you actually have this flexibility that you have these robots mounted on a platform, which includes a complete work area. You have everything, all tools, everything that you need in combination with the robot, and you move this with an AMR to the specific area of the line where you actually at the moment need this task. Like a human is doing this similar, the same. They are getting more work power, manpower together on this area of the production where you actually need this at the moment mostly. So what I want to show is, here we have seen also mobile AMRs before, but this shows how to use this in a very smart, flexible way. And you connect this then to the station. It is then they're immediately connected with air, with power, everything that you needed. So there is no need for any kind of integration. It is also by having then camera included with the markers to synchronize the robot coordinate system with the conveyor system and the workspace. And that means you can then, with the tool changes, do different tasks, and you can imagine how flexible you can be with this. And this is also all based on Orion. So each station have this as a base. And that means also that you can very flexible add or change something if this would be required. So this, and you might consider also, you see here, these are, I still say cobots. I know I'm not longer allowed to say cobots, so robots in collaborative applications. But why not using normal industrial robots? Because we have both. But here it makes, for me, really sense. If you combine an AMR with a robot, then for me, this is one typical example where a collaborative robot really makes sense, because the way of how to create the safety environment and everything. And then you still see scanners around. Why do you have scanners if everybody says, yeah, but a cobot is safe itself? Yes, but you see here that you have here an application where you have tools and some edges and sharp corners. That means you need to assure, if a human is close by the robot, that at least the robot becomes much slower, but not only in speed and accuracy and acceleration, but also in the force that can come from this. So that means here really having this combination of AMR with a collaborative robot in the flexible line concept is some kind of complete concept together. Also then, by having additional to the torque sensors for safety, force control sensor included in the arm, you can even do also more sensitive tasks in the same time without adding more additional external sensoric in this. So, and this is designed to run 24 hours, 7 days a week. The humans in these lines are more for sporadic interaction whenever it's needed. So therefore, they want to have an open line. But on the other hand, you see here also you're having AMRs included who are providing the materials, the parts towards the line. So it's really designed to run 24 hours, 7 days a week. Typical Japanese production philosophy. Yeah. I just wanted to present this to you as also giving a little bit more some view of how it's not so much AI here involved, but you can imagine step by step, this is moving forward. I just want to summarize. So I have presented Orion as a middleware platform for simplified and standardized communication between the automation on the application and the device level. And in order to enable seamless integration of PLCs, robots, motors, whatever is needed, into PC-based applications. And abstracts also the specific protocols and languages. So you're choosing one common high-level language, and you just use this in one defined structure for the complete machine line, whatever it is. And the last was to present the next generation of a flexible production system in an example how to use this Orion as a base, and also to give you a view how robotics today can be used more quite flexible. Thank you very much for your attention, and I'm looking forward to some interesting questions from your side. Thank you very much.
Thank you very much, Carsten. You definitely made up for your lack of singing skills with that great presentation. So,
thank you.
And here we already have our first question. Please go ahead.
When you have the mobile platform coming with a robot and all the tools that could ever be possibly needed in the production use case, aren't you over-equipping everything and then using only a really small tidbit of what is necessary?
Thank you very much. Honestly, I forgot to mention this. This shows an example of a quite large production. But if you ask me, if it's a little bit smaller production, of course, instead of having an AMR, just to moving this work platform from one to another place, I would consider this can also be done by carry this manually from one to another one, just having the robot on top of this. So it's not necessary always to include an AMR. It depends a little bit on the volume and the production concept in general.
Any other questions here in the room? You talked about SRCI at the beginning. So maybe you just need to clear that up again. Do you, Denso, now believe in SRCI or not so much?
Thank you for this question. Yeah, we actually have Siemens. We have a very long history when it comes to SRCI, and I call it the first generation from the SRCI standard communication. About 15 years ago or something, we were one of the first robot vendors who joined this SRCI interface. So it was at that time, we do have this interface, and it works. And we saying, look here, this is the way to communicate with the Siemens PLC. On the PLC side, we are in standard, we call it command slave, and it works fine. And but as mentioned yesterday, and thank you in your presentation, it's a little bit a chicken-egg issue. And what we faced, we have this beautiful interface since 15 years, and we were wondering that not everybody is running in our door, and please, we want to have it. And then when we have this had finalized, then the second version of the new version came on the market, and then it were up to say, okay, now we need to develop it again. So we need to start from scratch again, and let's say we are ready to start with this on the second generation, where we need some R&D from our side, and we just need to have a nice use case, or let's say the customers behind saying, yes, this is what we want to have. We believe in this because if you want to run this, if you want to make the program on the PLC side, yes, and to run the robot controlled from the PLC, yes, we believe in this. We have it established. It's in the first generation, but not yet in the final generation.
I think Gunesh was smiling. I think that's a good answer on the SRCI thing, yeah? Okay. Thank you very much. Okay, we have another one down here. Yeah.
Yes.
I have a question. Is it on?
It's on.
Yesterday, we have spoken a lot about the China invasion, and this China invasion is basically, let's say, based on low-cost equipment or
Yes.
lower-cost
Yes.
equipment. Such an automated factory can be a response in terms of economic output to the low-cost invasion from China?
Let's say, thank you, good question. This concept is, the whole concept is developed and designed by the factory automation group from Denso Automotive. There is a global group led by Japan. So this is an internal concept that, let's say, goes the Japanese, not the Chinese way. That is also related to not doing this on low cost, but doing this on reliability, quality, and of course it needs to fit also in the complete cost structure. But it's not that they are looking on these low cost concepts because it's not in the philosophy of Denso.
Okay. Thank you so much to you, Carsten. Big
Yeah.
round of applause to Carsten. Very good presentation. Thank you.
Thank you.
Thank you.